Hello everyone. Today let's continue with the yesterday's discussion or previous videos discussion. Previously we tried to compare that various APIs or we tried to bring up various APIs. We learned a little about it. And today we are continuing on that and we are trying to see which API can be used on which scenario and what are the advantages, what are the disadvantages, and what are the best features in each API, and comparing feature wise all those things in detail. Let us go over today. Okay, it's not specific to fast API, it is more over comparison of various APIs. Okay, let's get started. So the video is a part 2 and part 1 is a very basic level we have discussed in previous video. Yeah, this is about types of API as I said and comparison and when to use which one you will learn in this video. Okay.
API fundamentals. What is an API? A way for software systems to talk to each other. Let's applications share data and functionally. Previous video we discussed about various types of API. We will discuss now more detailed comparison, advantages and disadvantages, etc. REST API representational state transfer. REST API
is best for general web services.
Use
When to use? Simplicity, statelessness, and resource-oriented architecture are decided. In this particular scenarios, you can go for REST API.
Examples: e-commerce
website.
E-commerce website.
Exposing a product catalogs, orders, and customer data, get, post, such kind of scenarios, we will use REST in a e-commerce websites.
Social media apps.
Fetching user profiles and posts, social media apps is one of the example.
Mobile apps.
Interacting with backend resources via HTTP, for such scenarios, mobile apps will use REST API.
LOT devices.
IoT
devices.
Sending sensor data using lightweight HTTP, for that kind of scenarios, we can go for a REST API.
Public APIs.
Like GitHub, Twitter, etc. can be used by REST API.
CMS platforms.
WordPress, exposing content through REST API.
Why REST?
So it is a clean, URL based, widely supported, easily cacheable. That's why we can go for REST.
REST API disadvantages: overfetching, underfetching.
So no control over exactly what data is returned here.
Too many endpoints.
So there is a large APIs can become cluttered and hard to maintain.
Stateless only.
Can be limited for sessions or complex workflows.
Verbose for complex queries.
Yeah, handling joins or nested data is very messy in this REST API.
Focus instead.
So instead of these particular disadvantages, where we should focus when we are using REST API, it is simple CRUD and clear versioning, resource focused design. In such scenarios, we can go for REST API in spite of these 4 disadvantages. Let's go for a next API design.
SOAP API, Simple Object Access Protocol. SOAP API.
Best for enterprise grade applications.
Use when
Strict contracts and security and reliability are required. Such scenarios, go for a SOAP API.
Examples: banking systems,
Secure financial transactions can be implemented using SOAP API.
payment gateways,
Like PayPal, Classic, or so that kind of payment gateways can be implemented using SOAP API.
telecom billing,
So handling billing or subscriptions can be done using SOAP API.
government services,
Secure schema-driven services can be implemented using SOAP API. Example, government services.
healthcare systems,
HL7 over SOAP API can be done in healthcare systems. Is a SOAP API.
enterprises CRMS slash ERPS.
Like Salesforce integrations might be done in SOAP API.
Why so?
It is highly security, reliability, asset compliance, and strict contracts. That is why we can go for SOAP.
SOAP API disadvantages. Heavy weight.
SOAP API is heavyweight. It uses XML, which is verbose and slow to parse.
Steep learning curve.
Steep.
Steep learning curve.
Yeah, SOAP API has a very steep learning curve with WSDL, strict contracts, and tools. Tooling is needed.
Hard to debug.
So there is a less intuitive error messages in SOAP API.
Limited browser support.
So not easily consumed by JavaScript clients. So there is a limited browser support. These are the disadvantages.
Focus instead.
Instead of focusing on these disadvantages, enterprise grade security and strict contracts, transactional operations, if we want, we can go for a SOAP API and ignoring these disadvantages. Considering these disadvantages in low light. Okay, let's go for a next API design.
RPC. RPC API. Remote producer call API.
Remote procedure call.
RPC API.
Best for internal and lightweight services.
Use when?
You want to trigger functions directly with minimal overhead, then go for remote procedure call, which is RPC API.
Examples: internal microservices,
Like triggering or generate report in another service. That kind of scenarios, yeah.
chatbots,
Making direct calls like send message, user ID and message. For such things, RPC is better.
device management APIs,
Like restart device for IoT devices remotely. Yep.
automation scripts,
Triggering remote operations, like you want to trigger a script using a remote call. So this is RPC is better.
game engines,
Triggering server side logic from clients. For example, you want to trigger any server side, some robot is started coming or zombie is coming. You want to introduce in game, so that for that RPC is better.
internal testing tools,
Quickly call server methods via JSON RPC. That is possible using internal testing tools. That can be implemented.
why RPC?
RPC is very fast, minimalistic, good for internal or function based needs.
RPC, JSON RPC, XML RPC, disadvantages. Tightly coupled,
It is RPC is tightly coupled. Changes in method signatures breaks clients easily. So whichever consumes this RPC can break if you change any of your methods. So it can be JSON RPC or it can be XML RPC.
no resource concept,
It is very harder to document and version properly because of there is no resource concept. It is a completely very generic.
not self descriptive.
You need output of band knowledge to understand these APIs, and you will not have a lot of description available for this. And you need to produce a huge description based on the different inputs, different expected outputs, or different expected. So you need to produce a lot of documentation, but it is not self-descriptive.
Scalability issues.
More fragile in large distributed systems because of its scalability issues.
Focus instead.
So we should focus instead of these particular disadvantages if we want to go over simple method calls and performance in internal systems. You want to improve, then go for RPC. Let's go for a next API.
GraphQL API. GraphQL.
It is best for a complex front-end applications.
Examples. Use when
Front-end needs very flexible and efficient querying means go for a GraphQL.
examples. Dashboard apps.
Dashboard apps often fetch only necessary data, example user.name or number of orders or how many is delivered or only exact data, and you want to show the dashboard. That time you do lot of filtering at remote and get the only the data. That kind of time go for a GraphQL.
Mobile apps.
Reduce payload over a slow networks. Instead of that, run everything at a server side and get only minimal values to the mobile apps instead of running the filters at mobile apps. So for that purpose, this GraphQL is best.
B2B platforms.
Nested and dynamic queries can be done in B2B platforms using GraphQL.
CMS apps.
Frontend describes what content or fields to pull in the CMS apps. So that can be benefited if you use GraphQL. CMS apps can be benefited.
Single page applications SPA.
So React, Vue.js, AngularJS, such UIs can use GraphQL more, so that you will have less payload is exchanged between UI and backend. So that is useful when you are using React, Vue or Angular or similar UIs.
Dev tools.
APIs that support code interpretation, introspection or schema viewing. So for such dev tools can use GraphQL efficiently.
Why GraphQL?
Avoid overfetching and underfetching and provide exactly what the client wants. This is exactly against REST API. REST API doesn't support this, and GraphQL support this. Overfetch it avoids overfetching, it avoids underfetching, but there are some disadvantages too.
GraphQL disadvantages. Complexity
In backend.
Complexity in backend.
More logic to resolve nested queries. These queries will have to be implemented at backend server. So
Coaching in harder.
Caching is very harder in GraphQL since endpoints are very dynamic and HTTP caching is trickier. So we don't do normally for GraphQL, we don't do caching.
Overhead on small apps.
So may not be worth it for a simple applications. So don't go for a GraphQL API if you are having a very simple applications. So that this kind of overhead is not worth for small applications.
Security risks.
Can lead to comprehensive queries. DDoS-like risks if not throttled properly.
Focus instead now.
Focus instead flexibility for the front end and single endpoint and schema driven development. So that is why since it is a schema driven development and flexibility for front ends like for React JS, Vue.js, AngularJS, these are the things and a current trend. So GraphQL can be benefited for such kind of applications. Let's go for a next API.
gRPC Google Remote Procedure Call. gRPC API.
Best for high performance systems.
Use when
For a performance and streaming or polyglot communication is a key.
examples. Real-time recommendation engine.
So for real-time recommendation engine, if we go for a gRPC, it will have a low latency RPC between services.
Video streaming backend.
So for video streaming, gRPC is very efficient. Binary data transfer, for a binary data transfer also it is very efficient.
IoT networks.
It is IoT networks is one of the example for a gRPC. It provides high throughput and comparison with protobuf.
Microservices mesh.
So kind of Kubernetes internal services uses RPC. So kind of most of the microservice meshes uses gRPC, Google Remote Procedure Call.
ML model serving.
So high performance model inferencing this gRPC.
Mobile backend.
So compact payloads over slow networks. So if your network is slow, still this gRPC will beneficial for fetching the data in mobile. So mobile backend can be gRPC API.
Why gRPC?
It is ultra fast, language agnostic, and streaming support and protobuf efficiency.
gRPC API disadvantages. Not
Browser native.
native.
It is not a browser native. It requires proxy layers for web support.
So, sleeper learning.
It is very steeper learning, protobufs, strict typing, and tool setup. Lot of things are there to work with it.
Harder to debug.
So it is very hard to debug binary format and makes inspection trickier. So to debug it is very difficult.
Tight silent server contact.
Tight client server content and minor changes required for a regeneration.
Focus instead now.
Instead of focusing on these disadvantages, if our focus is on speed, efficiency, streaming, and multi-language support, then gRPC is best. Let's go for a next API.
WebSockets API. WebSockets.
It is best for real-time communication.
Use when
So you need a full duplex persistent communication, then go for a WebSocket.
examples live chat applications.
So real-time messaging between users can be used in WebSockets.
Online games.
Sync game states between client and server. You want to sync the state between client device and server device. For such things, WebSocket is best.
Live stock tickers.
So real-time stock updates can be used in WebSockets.
Collaborative editing.
So Google Docs style live updates uses this WebSockets so that you are editing in one page and the page is shared with others. Other people also seeing your live editing.
Notification dashboards.
Notification
systems.
Push alerts to users instantly is possible using WebSockets.
Monitoring dashboards.
So you can real-time logs and metrics can be monitored easily using WebSockets.
Why WebSockets?
Persistent, low latency, real-time communication can be done using WebSockets.
WebSocket disadvantages: stateful connection.
So it definitely requires a connection management and cleanup. Unlike REST API doesn't maintain connection. WebSocket will maintain stateful connection.
No standard
Caching. There is no standard caching for this WebSocket. Hard to optimize through CDNs.
Scalability.
It needs special infrastructure for many concurrent connections.
Not RESTful.
It is not RESTful, as I said earlier. REST is against this, and WebSocket is against REST again. So you lose benefits of stateless HTTP, but you will gain the benefits of stateful. Yeah.
Focus instead.
So instead of focusing on disadvantages, if we are focusing on real-time apps development, bidirectional and low latency data flow, for such scenarios, if you are developing your applications, go for WebSockets. Let's go for a next detailed comparison feature-wise.
Comparison table. Let us discuss future comparison across API.
So
REST.
Data format is JSON XML.
SOAP API.
So XML data format it supports.
RPC API.
JSON XML both it supports data format.
GraphQL API.
It supports JSON.
gRPC API.
Protobuf data format.
WebSocket API.
Any data format it supports. Next is communication style feature. Let us consider.
REST API.
It communicates resource style.
SOAP API.
It communicates based on the protocol.
RPC API.
Its style of communication is methods.
GraphQL API.
Its communication style is query.
gRPC API.
Its communication style is methods.
WebSocket API.
Its style is streaming.
Schema.
Let us consider schema now.
REST API.
Schema is not mandatory. It is an optional for a REST API.
SOAP API.
SOAP API follows WSDL schema.
RPC API.
It is schema is optional for a RPC.
GraphQL API.
It is mandatory for schema is mandatory for GraphQL.
gRPC API.
gRPC also schema is mandatory.
WebSocket API.
It is not required at all schema. Let us take the speed feature and comparing each API style.
REST API.
It is a moderate speed,
SOAP API.
slower compared to other APIs.
RPC API.
It is fast in compared to other APIs, RPCs.
GraphQL API.
GraphQL API also very fast compared to other APIs.
gRPC API.
It is blazing fast compared to any other APIs.
Finally, WebSocket API.
WebSocket API almost it gives the same way of Google RPC, gRPC. It's very fast. Let us take a feature of verbosity.
REST API.
It is a medium verbosity.
SOAP API.
It is a very high verbosity due to its XML format.
RPC API.
It is low verbosity because it is communicates only a limited content.
GraphQL API.
It is also low verbosity, communicates only a necessary content.
gRPC API.
Same low verbosity.
Fine, and finally WebSocket API.
It is again verbosity is low. Let us take that real-time support feature for
REST
each
API.
API.
REST API.
There is no possibility of real-time support because it is stateless,
SOAP API.
and it is also no real-time support.
RPC API.
It is limited real-time support.
GraphQL API.
There is no real-time support.
gRPC API.
Yes, there is a possibility of real-time support.
WebSocket API.
It is possible to have real-time support for this feature. And let's consider caching now.
REST API.
Caching is very easy for a REST API.
SOAP API.
It is bit hard for a caching to do SOAP while doing SOAP API.
RPC API.
RPC API is similar hard as SOAP for caching.
GraphQL API.
It is also hard to cache.
gRPC API.
gRPC API is super complex for caching.
Finally, WebSocket API.
There is no concept of caching for WebSocketing. And let's take use case.
REST API.
In general purpose simple applications, go for a REST API.
SOAP API.
If you have an enterprise applications
RPC API.
and you want to go for a microservices communication, then go for RPC.
GraphQL API.
So you have a complex UI, you want to communicate between UI and backend, and then go for a RPC API because of complex UI. Yeah.
gRPC API.
You wanted a high performance server which gives blazing fast, and so go for a high performance RPC. gRPC is best.
Final comparison table. WebSocket API.
It is you hunted a real time output, so then go for a WebSocket API.
Comparison table completed.
Let's go for next.
Which API? Final tip. There is no perfect API. The best one depends on your use case. Understanding what to ignore or be cautious about helps you play to each API's strength. In the upcoming videos, we will focus on REST API and use Fast API, Python application development.
Yeah, as we discussed, be cautious about which one to use, and best one is depends on your use case.
Thank you. If you like this video, give it a thumbs up. Subscribe for more Python plus Fast API content and let me know in the comments. If you want real project examples using Fast API, thank you. We will meet in the next video.
Thank you for watching. Have a nice time. Bye.